Today we're going to continue looking at graphs of both sine and cosine functions. So today we're specifically going to use vertical and horizontal shifts of these two functions. All right, so here is our basic definitions when we're dealing with shifting. So if we have y equals a times the sine of bx minus c plus d, and if we have y equals a times the cosine of bx minus c plus d. So there's four different components that we now want to look at. So in the past, we've looked at a and b to help us find amplitude and period. Now we have two more variables, c and d. So we have two more things that we need to identify. We have something called the phase shift. And so that's going to be the horizontal movement of the graph. Now, C is going to help us find that, but it's not just C. It's going to be C divided by B, okay? And just like all of our other transformations in the past, whatever sign we see, we're actually moving in the opposite direction for that phase shift. When we have the letter D, that's going to help us get our vertical shift. That moves up and down, and just like in the past, we do want to keep the sign that we see there. So let's first, before we even graph, look at a problem and just identify all the pieces. So we want to identify the amplitude, the period, the phase shift, and the vertical shift. We've got y equals 5 times the cosine of 3x minus pi over 6 plus 4. So to do these types of problems, the first thing that we're going to want to do is we're going to want to identify our a value, b, c, and d. Okay, because those letters are going to help us then find the four things that we're looking for. So remember, a is always the number that's in front of our trig function. So 5 is that number in this problem. B is the number that's always connected to x. So that would be 3 in this problem. Our C value is going to be then the number that comes after the x. But remember, I want to take the opposite sign. So because I see a negative pi over 6 inside the parentheses, that means C is going to be a positive pi over 6 because I always change the sign for C. The value for D is what number is being added or subtracted onto that function. And so for us, it's positive 4. And remember, I keep the sign the same. All right, so now that I've identified A, B, C, and D, let's find all the things that they're asking for. So to find the amplitude, remember, we just want to take the absolute value of A. Well, the absolute value of 5 is still going to be 5. So there's my amplitude. Then I want the period. So because we are dealing with the cosine graph, well, even if it was a sine graph, remember it's the same. It's always going to be 2 pi divided by the absolute value of b. Well, b is 3. The absolute value of 3 is just 3. So 2 pi over 3 would be the period. Now I want to move on to the phase shift. So this is the new stuff. The phase shift, remember, I defined it as c divided by b. So our C value is pi over 6. I'm dividing that by the B value, which is 3. So when I have a fraction, I can divide it by then its reciprocal. So the reciprocal of 3 is a third. Multiplying straight across, that tells me that pi over 18 is the phase shift. And then finally, we want the vertical shift. And so that is just whatever your value of D is. And in this case, D is 4. So there are the 4 things that they were asking for. All right, so let's use that information and now let's actually graph. All right, so we have y equals negative sine of x plus pi over 4. So once again, we're going to want to identify our A, B, C, and D value. So then we can identify what they're asking for. So in this one, I don't know why I didn't write it. Let's also identify the vertical shift. Okay, so let's identify all 4 things, and then let's go ahead and then graph one period. So remember, A is whatever number's in front of the trig. So in front of sine, I see -1. My b value is whatever number is connected to x. I don't see a number, so it's 1. My c value is whatever's in the parenthesis with the x, but now remember, I take the opposite sign. So because I see a positive pi over 4, I want a negative pi over 4. My value for d is whatever's being added or subtracted. Now, because I don't see a number there, that means that d is 0. So to identify the amplitude, remember it's the absolute value of a, so the absolute value of 1 is 1. Or sorry, absolute value of negative 1 is 1. My period is going to be then 2 pi divided by the absolute value of b. Well, absolute value of 1 is 1, so 2 pi is my period. My phase shift, remember, is always going to be c divided by b. So c is negative pi over 4. If I divide that by b, which is 1, that means negative pi over 4 is my phase shift. And then my vertical shift is going to be whatever d is. So in this case, because I have d as 0, that means there is none. All right, so I've got all that information, and I'm going to use all this information to now graph. So we have to find our 5 critical points. So what we're going to do is we're going to start off by finding the 5 critical points like we would without C and D. So let's do like we did in yesterday's lesson. So when we have a sign graph, remember we always start at 0, 0. Then I want to do a fourth of the period. So remember, if our period is 2 pi, when I'm taking a fourth of that, it's going to give me pi over 2. And then I want to have the a value. So our a value is negative 1. Then I want half of the period. So half of 2 pi is pi, and then we're back at 0. Then I want 3/4 of the period. So 3/4 of 2 pi is going to be 3 pi over 2. And then I want my opposite of a. So if a is negative 1, the opposite would be positive. And then I want the full period, which is 2 pi, and we're back at 0. But now those are not the points that I'm going to actually graph because we are now dealing with shifting. So I want to take the C and the D values, and we're actually going to create then 5 new ordered pairs that we are actually going to want to graph. So the C value, once again, think about the alphabet. C comes before D and X comes before Y in an ordered pair. So the phase shift that we identified, so not C, I guess, the phase shift and the vertical shift are what we want. So it's these 2 pieces right here. These are what we're going to use. This one, we're going to affect the X values. And then the vertical shift is going to affect the Y values. Okay, so in this case, negative pi over 4 is what I need to then add on to all of my x values. And then 0 is what I'm going to add on to all the y values. Okay, so if I take 0 and I'm subtracting pi over 4, I'm going to have negative pi over 4. And then 0 plus 0 is still 0. If I have pi over 2 and I want to subtract pi over 4, you have to think about common denominator. Okay, so when I'm thinking about pi over 2 minus pi over 4, well, not the same denominator. So over here, I can multiply the top and the bottom by 2. So really, this is 2 pi over 4. Okay, so this is what I'm subtracting. So 2 pi over 4 minus pi over 4 is going to give me a positive pi over 4. So that's the first number. And then negative 1 plus 0 is still negative 1. All right, then we have pi, and I want to subtract pi over 4. So remember, pi is really like over 1. So you're going to have to multiply the top and the bottom by 4. So you're thinking 4 pi over 4 minus pi over 4. That's going to get me my next x value. So that would then be 3 pi over 4. And then once again, no vertical shift. So essentially, all of my y values are going to stay the same. It's only the x values that are actually going to change in this particular problem. When I have 3 pi over 2, I'm going to turn that into a denominator of 4 by multiplying the top and bottom by 2. So remember, 6 pi over 4 is the same thing as 3 pi over 2. When I subtract pi over 4, that's where we see that we get 5 pi over 4, and then we'll have positive 1 still. And then 2 pi, we can think of that then as 8 pi over 4. So that means we would then have 7 pi over 4, 0. Okay, so as far as then what we want to actually plot, well, we are going to be plotting these 5 points on our graph. So those are the x values that I want to be labeling on my x-axis. And once again, we want to be very consistent with the how far away we space out each of our tick marks. Okay, so I'm going to make each tick mark pi over 4. So that means on the left, the first tick mark is negative pi over 4. Then it would be negative 2 pi over 4. Then it would be negative 3 pi over 4. Then negative 4 pi over 4, and so on. So this on the right side is positive pi over 4. Then it's 2 pi over 4. Then it's 3 pi over 4. 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And that's how I'm going to keep thinking about my tick marks. I'm going up and down by pi over 4 each time. All right, my y-axis is already labeled for me, so now I can plot my points. So negative pi over 4, 0, pi over 4, negative 1, 3 pi over 4, 0, 5 pi over 4, positive 1, 7 pi over 4, 0. Okay, so notice that I am going to want on the left side, I'm going to be going up once I'm continuing on the left. So that's why my arrow starts going up, but then I'm going to curve, and then I'm going up, and I'm curving, I'm going back down to 0, and then I would then head down for the next one. So there is my 1 period graph. All right, let's do another one. This time, let's look at a cosine. So we are going to graph y equals 2 times the cosine of x plus 1. So we'll identify, once again, amplitude, period, phase shift. I don't know why I don't have this written. Sorry, vertical shift. We're going to identify all 4 of those things, and then we'll graph one full period. So once again, I want to identify my A, my B, my C, and my D, so then I can identify those 4 pieces. So once again, A is the number that's in front of my trig function, so 2. B is the number that's in front of x. When I don't see a number, it's a 1. Because there are no parentheses, that means that there is no C value, so that's 0. Because I'm adding on to that cosine, that's going to be the D value, and remember, I keep that sign the same. So now that I've identified that, we can identify then our amplitude. So remember, it's the absolute value of A. So the absolute value of 2 is still 2. For the period, we are going to take then 2 pi and divide it by B. Well, B is 1, so 2 pi divided by 1 is 2 pi. For the phase shift, remember, it is going to be C divided by A. Well, C is 0, B is 1, so it's 0. So that means there is none. There's no phase shift. Okay, and then my vertical shift is whatever my value for D is. And so in this case, that would be a positive 1. Okay, so now that I have all of that identified, I'm going to list my 5 critical points. And we will start off again by ignoring the phase shift and the vertical shift. So we'll ignore this part, and we'll just focus on my 5 original critical points where I'm using A and B, or A and my period, in order to do that. So remember, with a cosine graph, it doesn't start at 0, 0. It starts at 0, A. Well, my A value is 2. So 0, 2 is where my original first critical point is. Okay, because my period is 2 pi, oops, what am I doing? I want to once again start breaking up 2 pi into quarters. So a fourth of 2 pi is once again pi over 2, and then we are at 0. Then I want half of the period, so that would be pi, and then we are at the opposite of A, so negative 2. Then I want to have 3/4 of that period. So 3/4 of 2 pi is 3 pi over 2. I'm back at 0. Then I want the full period, so 2 pi, and then we're back at our A value, so 2. So then remember, the phase shift is going to affect the x values, and the vertical shift is going to affect the y values. So luckily for us, the x values are not changing because we didn't have a phase shift. So I am going to be adding 0 onto it, so that's not going to change. Vertical shift is a positive 1, so I'm going to be adding 1 onto all of those. Okay, so we're going to have then 0, 3 as our starting point. We'll have then pi over 2, 1 as our second critical point. Pi negative 1 is the third. 3 pi over 2, 1 is our fourth. And then 2 pi 3 is our last critical point. So once again, then, it's the new critical points that I am going to actually be plotting. So I want to look at these x values in order to then look at my x-axis here. So notice how 0, it goes 2 pi. So I'm going to be going up and down by 2 pi every time. It's just a matter of how far apart do I want my tick marks to be. So I think I'm going to space them out as every 2. So here is pi over 2. So then I go 2 more over to get to pi, and then 2 more over to get to 3 pi over 2, and then 2 more over to get to 2 pi. All right, so now that I have my x-axis labeled, we can plot our points. So 0, 3 starts us off, pi over 2, 1, pi, negative 1, 3 pi over 2, 1, and then 2 pi back up at 3. All right, so once again, remember, with a cosine graph, those points at the top are the highest. So I have to make it where they are curving, where I'm not going to have an arrow pointing up farther than 3. 3 is the highest. So then now we are curving down, and now we're curving up. And once again, I have to make that arrow curve down nicely. I don't want it pointing up. There is my cosine graph. Okay, let's do one more together. Once again, we're going to identify all 4 of these. Okay, so we have y equals 3 times the sine of 2x minus pi over 3 minus 1. All right, so a lot of stuff going on here. So let's identify A, B, C, and D so we can start figuring all this out. So my A value is the number in front, so that's 3. The number connected to X is B, so that's 2. Remember, C is whatever's in parentheses, but we take the opposite sign. So since it says minus pi over 3, I want a positive pi over 3. And then the value that's being added or subtracted from that trig function is going to keep that sign the same. So that's my D. All right, so remember, amplitude is the absolute value of A. So absolute value of 3 is 3. My period, because its sine and cosine graphs are the same, it's 2 pi divided by the absolute value of B. Well, absolute value of 2 is 2, and so 2 pi divided by 2 is pi. All right, phase shift is going to be C divided by B. So my C value is pi over 3. My B value is 2. So remember, I'm going to take pi over 3 and multiply by the reciprocal. So the reciprocal of 2 is a half. So that means that pi over 6 is my phase shift. And then my vertical shift is whatever that D value is. So that means that we are going to keep negative 1. So remember, this is going to affect the X values. This is going to affect the Y values, but I first just want to find my 5 original critical points. All right, so notice that we are dealing with a period of pi this time. So we're also dealing with a sine graph. Remember, with the sine graph, we start at 0, 0. Now I want to take a fourth of pi. So that's going to be pi over 4. And then we want our A value. Well, our A value is 3. Then I want half of the period. So half of pi is pi over 2. Then I'm back at 0. Then I want to take 3/4 of the period. So 3/4 of pi is 3 pi over 4. And I want the opposite of a, so -3. And then I want the full period, so pi, and I'm back at 0. Now, once again, those are not what I'm going to be plotting. I'm going to be creating my 5 new points based off of my phase shift and my vertical shift. So that means we are going to be adding pi over 6, because that's the phase shift, onto all the x values. And we're going to be subtracting 1 onto all of the y values. So once again, notice how some of them, like the first one, 0 plus pi over 6 is pi over 6. So that isn't a problem. And 0 minus 1 is -1. So that ordered pair isn't bad. But now, once again, notice how we have different denominators. We have a pi over 4 and a pi over 6. So we have to find a common denominator for both of those. Okay, so I'm going to have to erase this. But pi over 4 plus pi over 6. What's the first number that they both have in common? 12. So I'm going to multiply this fraction by 3 on both the top and the bottom, and this one by 2. So we have 3 pi over 12 plus 2 pi over 12, which is why then, I'm running out of room here, but when I add that together, that means I'm going to have 5 pi over 12, and then 3 minus 1 would give me 2. So there's my next order pair. All right, so then we're looking at pi over 2 and pi over 6. Well, pi over 2 plus pi over 6, common denominator would be 6. So I just have to multiply the first fraction by 3. So 3 pi gets added onto pi, so that becomes 4 pi over 6. And I can simplify that. 4 pi over 6 is the same thing then as 2 pi over 3. And then 0 minus 1 is -1. All right. Then we have 3 pi over 4 and pi over 6. So once again, denominator of 4 and denominator of 6 means that 12 is that common denominator. So I multiply the first fraction, top and bottom, by 3, second one by 2. So we'll have 9 pi over 12 plus 2 pi over 12. Well, 9 plus 2 is going to be 11. So 11 pi over 12. And then -3 minus 1 is -4. And then finally, with it being pi, we can think of that as 6 pi over 6, because I want to have that common denominator of 6. So then that would give me 7 pi over 6. Oops. So 7 pi over 6, and then 0 minus 1 is -1. All right, so took a lot of us thinking fractions, but now notice that a lot of my fractions have different denominators. So we have to understand then, what are we truly like going up and down by? And so it really is that phase shift that's going to help us out, okay? So, well, how do I do this? Well, I guess the biggest denominator is 12. Okay, so let's think of it that way. Okay, so if 12 is the biggest number in the denominator, let's use that as a reference. Okay, I'm gonna go ahead and I'm gonna make like every tick mark pi over 12. So let me kind of then explain my thought process here. Okay, so I'm not going to label every single tick mark on here, but this first one is pi over 12. So then the second one is 2 pi over 12. Then we have 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7, 8, 9, 10, 11 pi over 12. Okay, so notice that like 5 pi over 12, I need for it 11 pi over 12. So notice how 2 pi over 3 is really a denominator of 12. It's when I multiply the top and the bottom by 4. So that really is 8 pi over 12. Okay, and notice that pi over 6 is a denominator of 12 if I multiply the top and bottom by 2. So that's 2 pi over 12. And then as far as 7 pi over 12, we'll multiply the top and bottom by 2. That's 14 pi over 12. So I know that I need to have tick marks 11, 12, 13. Here's 14 pi over 12. So I need to make sure that I can go up to 14 pi over 12. So hopefully that makes sense. So when you're looking at all those different denominators, pick the biggest number in your denominator and then use that as a reference. Okay, so remember, pi over 6, -1. So here, my x-axis was labeled, now my y. So I'm going up and down by ones, okay? So they're my x and y axis. And so, like I said, you don't have to necessarily label every single tick mark, but I need to know what your scale is for your tick mark. So if I can't clearly identify what your scale is, that's a problem. All right, so we want to go over to 2 pi over 12. So the second tick mark on my x-axis, and then I want to go down to -1, plot my point. Then 5 pi over 12, I want to go up to +2. Then I want to go over to 8, so 5, 6, 7, 8 pi over 12, and then I'm down at -1. Then I want to go over to 11 pi over 12, and then down to -4. And then I want to go to 14, so 11, 12, 13, 14, and I'm back at -1. Okay, and so notice that when I'm connecting on the left side of that first point, it would be heading down. So I'm knowing that I'm going to need an arrow pointing going down. So I'll curve up there at the top, I'm hitting my next point, curving to go back up, and then from there, it would be heading up as well. So there is one sine period. Okay, so that's us using vertical and horizontal shifts of these sine and cosine functions.